Riley, thanks for your question. So we now know by de Moivre's theorem that if we want to put z into polar form, z squared would be r squared times cosine of 2 theta 1 plus I sine of 2 times theta 1. Similarly, if I want to cube z2, which would be a different z in this case, what I'm going to do is just cube r and then multiply the angle by 3. In this case, I'm actually given z2, which is going to be very helpful, but unfortunately I'm only given z1 squared in complex form, so we're going to have to figure out what that is. Let's go ahead and look at what our goal is. If we're going to take z1 squared divided by z2 cubed and put that into polar form, what we're going to have is r1 squared over r2 cubed times cosine of 2 theta 1 minus 3 theta 2 plus I sine of 2 theta 1 minus 3 theta 2. These two parts right here are coming from the quotient formula for complex numbers that you should have in your book. Let's go ahead and fill in what we know so far. So we are given z2 cubed in polar form already. So this is equal to r1 squared, which we don't know yet, over 8 times cosine of 2 theta 1, which we don't know yet, minus 3 theta 2, which we know to be 240 degrees, plus I sine of the same angle. So let's figure out what r1 squared and 2 times theta 1 are. I'm going to go ahead and take my a and my b, where my a is 4 and my b is negative 4, and I'm going to draw them on an xy axis. So if I go out 1, 2, 3, 4 in the x direction for a, and I go down 1, 2, 3, 4, 1, 2, 3, 4, almost. If I go down negative 4 in the y direction for b, I end up with the point 4, negative 4, and I can find out the magnitude of this line and this angle from this pair of points right here. So I know that if I wanted to find r in this case, r is equal to the square root of a squared plus b squared. But in this case, I'm actually looking for r1 squared. So r1 squared is even easier to find. It's just a squared plus b squared. In this case, we know our a to be 4 and our b to be negative 4. So 4 squared is 16 and negative 4 squared is 16. We're going to add those together to get 32. Now let's go ahead and find theta 1. I know that the tangent of theta 1 is going to be b over a, which is negative 4 over 4, and that simplifies to negative 1. Theta 1 in this case would be negative 45 degrees. But in the interest of keeping our angles positive, let's go ahead and call that positive 315 degrees. And we'll simplify those angles at the end. So what I have here is 32 over 8 times cosine of 2 times theta 1. 2 times theta 1 would be 630 minus 240 plus I sine of 630 minus 240, and those are both degrees, of course. Let's go ahead and simplify. Simplifying, 32 over 8 is, of course, 4. And this term turns into cosine of 630 minus 240, which is 390, minus I sine of 390. 390 degrees is what I get if I go around my circle once to 360 degrees, and then I go 30 more degrees. So we're going to simplify 390 to the angle between 0 and 360 here. This is actually equal to 4 times cosine of 30 degrees minus I sine of 30 degrees. And that'll be your final answer for this question. Thanks again for your question, Riley, and I look forward to answering more of your questions using Snap Math in the future.